Have you ever been to a dance performance with someone skilled in that particular style? You may notice them twitching next to you in the audience. You might even have to tell them to be still. The reason behind this is mirror neurons. Mirror neurons were first discovered in monkeys. MRI scans showed that the same neurons lit up when a monkey grabbed for an object and when it simply watched another monkey grab for it. This led to the discovery of a set of brain cells found on either side of the head that can't tell a difference between seeing and doing an action it has learned, mirroring the behavior of another. Mirror neurons, located primarily in the sensory motor cortex of the brain, are visual motor neurons that send excited signals when observing a specific motor act or when performing a similar task. This image of the lateral view of a human brain highlights the key areas involved in cortical action and sensory processing, where most mirror neurons make their connections. This explains why humans are able to experience the pain or emotions of another simply through watching the movements of another's face. It is how we empathize with another person. Scientists are now saying that mirror neurons have been key to human evolution. They are what allows us to learn quickly by looking and copying, so we can relate to the world and learn from the mistakes of others. For dancers or anyone trained in a specific physical activity, mirror neurons will activate when they watch the type of dance they are trained in. But for someone untrained in that activity, there will be little mirror neuron action. For example, let's say we show a video of a ballet dancer to a non-dancer. This image shows their brain with little mirror neuron activity. This time we show the video to a ballet dancer who knows the movements. Here we see the neurons lighting up in the same areas as if the observer is performing the movements themselves. Here is the brain of the dancer who is actually performing the movements. We see the most neuron activity here. Once the brain has learned a skill, it may simulate the skill without even moving, through simple observation. This has huge implications for injured dancers. Even if they may be unable to move, they can still retain a skill simply by watching others. Scientists are discovering more about mirror neurons and their applications every day. So next time you feel happy when you see your friend laughing, think about the mirror neurons lighting up in your brain.